So I come from a project that's responsible for collecting, archiving, and distributing a lot of data that pertains to Earth observations. So why does NASA do this? NASA's role is to one of the statements in the NASA 2014 strategic plan says we need to advance knowledge of Earth as a system to meet challenges of environmental change and to improve life on our planet. So NASA's Earth science data systems play a very important role in supporting this objective by providing end-to-end capabilities to deliver data and information products to users. And NASA has an open and free data policy, and it promotes usage of data by a large community. There is no period of exclusive access, which means data are available as soon as the satellites are launched and instruments start collecting the data. And there is a period of initial checkout, which may last a couple of months, maybe 3 to 6 months. After that, the data are available, and there is no period of exclusive access. PIs of instruments don't hold on to their data until they milk the data for their own publications and then release the data. It's a no period of exclusive access policy. And data are available at no cost to all users on a non-discriminatory basis, except where agreed upon with international partners. We do deal with international partners from Europe and Japan and Canada and other countries. And if we have an agreement with them that says we're going to hold on to the data and we're going to charge for those data, we do. But otherwise, data are available at no cost to all users. The acronym EOS-DIS stands for Earth Observing System Data and Information System, and it is a key core capability in NASA's Earth Science Data Systems program. EOS-DIS provides end-to-end capabilities for managing NASA's Earth science data from satellites, aircraft, field measurements, and various other programs. And EOS-DIS provides science operations, which includes data processing, data management, interoperable distributed data archives, which I'll talk about in a couple of minutes, and online data access services. Most of our data are online, so we provide online data access services, and Earth science discipline-oriented user services, which means there are individuals, people at our archive centers who answer questions with some familiarity with the utility of the data and how the data have been produced, and access to actual scientists who can answer further detailed questions. And we, of course, also need to provide network for transporting data to distributed system elements. So what kind of data do we archive and distribute? They are coming from various satellites. This figure shows multiple satellites that have been launched and are operating currently. And also aircraft data, as shown in the right corner here. That's only one example of aircraft mission. And there are a large number of those that have a number of instruments on board aircraft, and aircraft campaigns are conducted. Also, field experiments, which are ground-based or ocean-based measurements, are done as well. And the intention of this picture is also to show that there are multiple disciplines, like ocean biology and ocean surface topography and sea surface winds, temperature, moisture, atmospheric properties, land properties, and ocean properties. All kinds of measurements of the Earth are being taken by various satellite instruments and aircraft instruments and earthborne or ground-based instruments. We are a very distributed system. We have 12 different archives where data are stored. And the archives are called DACs, or Distributed Active Archive Centers, and there are 12 of them. There are 4 of them locally at Goddard Space Flight Center in Maryland, and you've got one in Alaska, one in Huntsville, Alabama, and JPL in Pasadena, California, and so on. So there are 12 of these. And we process data from 10 different satellite missions. Archiving and distribution is done from 38 missions, instrument product support for 87 different instruments. These numbers change over time. These are current as of end of FY13. And we had 6,861 unique different products, and we had 1.7 million users around the world. And in 2013, we distributed 839 million products to this large community. So we are very active as an archive. And the first of the satellites that we were responsible for got launched at the end of 1999. And since then, the number of products distributed in the community has been increasing somewhat exponentially, as you can see from this curve. And in FY14, I think we're going to exceed 1 billion quite easily, looking at the trend. As far as preservation is concerned, which is what this meeting is all about, NASA is not designated by Congress as a preservation agency, permanent archiving agency. But that doesn't mean we can throw away our data. We need to maintain. We spend billions of dollars collecting the data and processing them, and so we do need to maintain them for posterity. We need to maintain a research archive as long as there is scientific research interest, and we need to transition the responsibility to those are agencies that do have permanent archiving responsibility. Research archive responsibilities, of course, persist well beyond lives of missions. A satellite may last 10 years or 15 years or something like that, but the interest in research, earth science research, is going to extend way beyond that, maybe of the order of 50 to 60 years. And NASA works with other agencies for long-term preservations. We need to cut agreements and decide what kind of data we need to transition and so on. So NASA has to ensure data and other critical items are preserved and made available to the permanent archiving agencies. So in terms of general requirements of preservation, we shouldn't lose bits. We need to maintain discoverability and accessibility, readability, understandability, usability, and reproducibility of results. I've probably forgotten some abilities, but it'll be there. Okay, so for this reason, NASA recently developed preservation content specifications for earth science data, which includes a list of all the things that you need to keep. It's not enough if you just keep the bits. You need to maintain the understandability and readability and so on. Therefore, you need to keep other content. What are those content? That's what the content specifications document addresses. And NASA also participates in the Earth Science Information Partners, or ESIP, Data Stewardship Committee, on an emerging provenance and content standard. It's actually the preservation content specification was derived out of some work that we did with the ESIP Federation. So this gives you an example of the categories of content that need to be preserved, like pre-flight, pre-operations. Anytime you launch, anytime you launch satellite, before that you have pre-flight and pre-flight operations, operational data. Science data products, of course, need to be preserved. Science data product documentation, mission data calibration, science data product software, science data product algorithm input, product validation, science data software tools, and so on. So all these things need to be preserved, and the document provides a lot more detail on what exactly needs to be preserved and why. And that's it for now.